I have seen. It seems I saw a cat.
He wants to join.
The live events are so unpredictable.
Excuse me, Safia, can I ask you to change your name in Jitsi so it's easier to recognize you?
It is active, no problem.
Yes, yes. Just to recognize your icon in the screen.
The connection seems a bit shaky from there.
Mm-hmm. Anna, you are a PhD student?
Yeah.
Which year are you attending?
Second year.
Yeah. Oh, nice to see you now, Safia. Can you also write
Thank
down your name? Is it possible for you to change the name of your connection? I don't know.
Okay.
Okay. If you click on your name in Jitsi, okay, you can edit it.
Okay.
Yeah, wonderful.
Thank you.
Thank you very much.
Welcome.
Okay.
I don't know anything. I haven't received anything from Okba. I would say just to wait a couple of minutes, just up to 15, 20, and then we are going to start. And I'm sure Okba will join us later. Okay.
Yes. If Okba isn't there, we can really change the
Okay.
order, I guess, because it's not
Yeah.
a big issue.
Of course, yes.
Well,
But
I've sent a message
I'd
to him on
like,
mail.
yes, I'd like better to have him in order to meet all together
Yes, sure.
and to share this session.
We'll see how things go.
Are you in Biskra, Safia?
No, I'm in Bijaya.
How's the weather there?
It's good.
Okba, welcome here.
How are you?
Nice to meet you
Thank you. I'm glad to see you.
after such a long time.
Yeah, thank you.
I think we can start now.
Sure.
Okay, nice to have you. I am so glad, dear friends, to have you here. And I'm going to coordinate this session with my young fellow, my young colleague, Diego Altafini. And this session I'm going to coordinate is entitled Computerized Evaluation of Economic Activities, Urban Spaces. We have 4 presentations, and the order is first our presentation, which will be presented by Diego, and then yes, Ana Luisa, and then Okba, and finally by Safia. And so we have quite a long time. I would say that we can provide each of you with 20 minutes for the presentation in order to have 3 minutes, about a couple of minutes, 3-4 minutes for a short discussion. And yes, nothing. I'm glad, and so I'm glad I can invite my friend and colleague Diego to present the first paper, and the title is Territorial Disparities in Tuscany Industrial Assets, a method to assess average firm size spatial distribution.
So,
Diego, it's yours.
It's Ecco. This one. So everyone can.
Just a second.
Sure.
You have to share the screen. Ah, yes, sure. Schermo 1. This one. Let's see Schermo 2.
Yeah.
So you can all see the presentation. If you give me the okay, I can go. So hello to our colleagues. I am pleased to host this session with Professor Valerio Cutini here at ICCSA, and we'll begin the discussions with our paper that is treats about a method to assess the average film size and spatial distribution within Tuscany. So, where is the mouse? It's gone.
Yes.
Okay. So, in economics, firm size it's interpreted as an important marker for the economic activity's dynamism, as it indicates the scale of the operation and the conditions regarding production profitability of a determined sector. While it was firstly interpreted as a value derived from the number of contractual relations between firm and the other firms in the industry. Nowadays, several variables can be used to evaluate firm size. Those are intangible variables such as added value or net worth, or even material factors such as the volume of production, labor, and total assets. To these variables, we can also add systemic variables associated to the territories. In this aspect, we can consider market size or the presence of absence of a developed transport infrastructure. From a territorial standpoint, however, it is still hard to evaluate film size, as most of these economic variables lack a defined territorialization. While in the economic analysis, this isn't a hindrance, as territories are often abstracted and homogenized as spaces. For detailed urban and regional purposes, this is quite important, as it is a demand to us to identify where certain dynamics happen. Indeed, the spatialization of such economic variables is indispensable to aid the decision makers to identify the points of exposure in urban and regional space. So, given these demands, our objective with this work was to propose a method to spatialize and evaluate the average film size distribution within Tuscany, as well to understand the dynamics. To understand the dynamics and data limitations in this work. So, as stated, economics have several manners to evaluate film size. Those evaluations can be made from input variables that in general are related to what makes the firm function, in this sense, capital, labor, and build structures, and also in output factors that are instead the results attained by the firms, thus the volume of production, profits, and etc. In this aspect, we can say that film size, an average film size, can be estimated from both sides of the firm. The method we use in this work interprets size in its most fundamental way, based on the labor input factor. In that regard, we use two variables, the number of local units, which represents the number of individual firms in a determined area, and the number of employees. These variables are available to us in the Italian industrial and service census, and have a general territorialization being spatialized in survey areas, the census zones. The densities, or what unveils the territorial patterns of distribution, are calculated through the ratio of the absolute number of these variables by the total area of the census zones. In this aspect, we use three relations that are described in this slide. First, we determine the number of firms in a determined census zone, this first relation here. Then we determine the number of employees in a determined census zone, and then make a ratio of these two variables to determine the firm size, which is the number of employees divided by the total number of industrial units or economic activities in a determined space. Non so perché questo. In this aspect, associated to the firm size. We later intersected the variable related to firm size with the location of the built structures dedicated to production. Then we evaluate the predominance of administrative or productive size in certain parts of territory given the presence or absence of buildings dedicated to the production. It's important to note that these relations were calculated for 2001 and 2011, which allows us to make a diachronic comparison. So to the results, the average firm size specialization demonstrates a very distinctive pattern within Tuscany, as the concentration of areas with high density happens at the centermost areas of the urban spaces. To a lesser degree, is also identified that several areas that make the connection between these urban spaces and are marked by the presence of important highways also present a good amount of density of firms. It's important also to highlight that in general, the distribution of average firm size follows the distribution of average local units and average employees densities, in the sense that the maps are essentially, from a territorial standpoint, similar. The table indicates, however, that there are significant variations for the local number of units and local number of employees densities between the years, which indicates a decrease in the higher densities and an overall degrowth of the firm presence within the urban areas. These firms tend to move towards the outskirts or the boundaries of the urban centers. In a dynamic that portrays the tendency of expansion patterns in areas that had previously low or very low concentration of firms and employees. Still, between the years, the general dynamic of macro-territorial distribution is maintained. For medium and low densities, as I said before, they are predominant in the boundaries of the urban centers, also in the urbanized hinterlands that are close to these urban centers. Indicate that there is a strong territorial concentration of industrialization in Tuscany. This dynamic is also distinguishable between the two main parts of Tuscany, between north and south, as northern areas tend to concentrate the spatial distribution of firm size, where the immediate hinterlands possess a sufficiently high density, whereas in the south we have the concentration only on the small areas that comprise the largest urban areas within the area. And the hinterlands are or based with or a very low concentration of indexes of film size, or are devoid of films whatsoever. This is a very distinguishable characteristic of the Maremma area between Grosseto and Siena, which is an area focused on agricultural activities. Regarding firm size density variations between 2001 and 2011, those follow the suit verified for local units and employees, which decrements exist on the higher ranges, as it's possible to see here, where the red slightly diminishes in presence, and by a slight increase of medium areas, areas with medium density. These results reinforce that there is a territorial logic of expansion oriented towards the city's boundaries, observed in the implied image. Where a slight increase of yellow and green areas is verified. While regional analysis reviews the patterns of distribution, certain dynamics can be better observed within the area that comprises the largest presence of firms, that is the Arno River area. So we can better address how the territorial dynamics are reproduced in the remaining areas through the assessment of this small piece. For local units, as pointed out, very low and low ranges exhibit expressive growth in densities between 2001 and 2011, as the areas indicated in the green ellipses. You see that we have a way greater presence of green colored areas. Medium areas instead suffer a slight decrease, above all visible in the Lucca area. Still, the general patterns of distribution, as you can see, remain the same. Employees' densities also exhibit an expressive growth, above all for the lower ranges. In this aspect, the previously occupied hinterlands that had a small or a low density tend to increase this density between 2001 and 2011. It is also visible for the median areas that, for example, in this area around the city of Empoli, that demonstrate a greater increase in the boundaries distribution. As stated before, the average film size follows the dynamics of growth and decrease in the previous variables. However, differently from the previous data, medium areas tend to also be increased, as we can see in the metropolitan area of Firenze and Prato. This shift is due to differences in growth of the number of employees in the region, and we can relate this to the expansion of certain sectors and certain areas of the productive tissue, especially around Prato. The logic of the industrial films expansion verified per Prato can be highlighted when the film size database is intersected with distribution of its structures characterized as industrial. It's possible to see that the increases in the presence of purple areas indicate that the most expansions regarding the productive sector occur in these boundary areas. The tabular data, however, reveals that several areas become devoid of industrial activity across Tuscany during the period, a possible effect from 2008 global economic crisis. In that aspect, we can perceive that there is a tendency of decentralized concentration, as firms tend to relocate to spaces with better territorial support near the large urban settlements. So, in conclusion, film size is an important indicator of economic activity scale and dynamism, especially relevant to evaluate the industrial sector. While the analysis uses only one of the multiple ways to evaluate film size, it also reveals internal territorial disparities for the Tuscany region. From a regional standpoint, no significant territorial shifts occurred during the period 2001-2011, in the sense that territorial patterns were maintained, as average film size tend to be higher in urban centers or in proximity to important highways. What changed, and the shifts were punctual in this aspect, was the distribution of the densities in the boundaries of the cities, as very low and low densities tend to increase in these areas. Overall, the results demonstrate that these areas tend to provide a better support for the economic activities, as they can use the network, the accessibility to the network and to the rest of the Tuscany that is stronger on these areas. In this aspect, further researchers aim to address other variables, especially output variables, to address film size. As an example, the volume production and the productivity and the profits, as well to integrate these variables of dimension of film size to a territorial exposure index. So thank you for your time, and I am open to answer any questions.
Thank you, Diego. Thank you. You have done a very good job, a brilliant job in summarizing all the results or all the things you had. And is there any question for Diego from you all connected, Anna or Safia or Okba? Is there any question from you? Okay. There is no question, and so I take the microphone and
Sure.
as your chairman, Diego, please
Okay.
let me please ask you to briefly hint at the main weaknesses or
Sure.
criticalities of the method that you have presented so far, and which possible direction should be taken in order to search for further development of the research.
Sì. So the main problem, as we might imagine, is data. In the sense that, as I explained before, economic data has a very, how can I say, abstracted, to say the least, territorialization, in the sense that we have the data regarding the profits and have the data regarding the volume of production of the industries, but this data is available only at the macro scale. In the sense, we cannot pinpoint the places where these values are effectively within the territory. And this is how can I say, is most comprises also the future of the research. That is to try to integrate this economic data that is naturally abstract, develop a method and a manner to integrate to the areas where the built structures are located and to try to observe what patterns are revealed from this. Still, this is a very, how can I say, a very not to say difficult, but a very challenging work, because we have the restrictions that are imposed on us in the territorialization of the variables. This is the main problem.
Okay.
But it's basically this.
That is your research horizon. Thank you very much.
Thank you.
Diego.
Diego, I think I have a question. I don't know. Okay. I would like to ask if there is a methodology to predict future changes. I mean, like plugin or something on GIS in order to predict future changes.
Yes. Well, this is an interesting question and makes us think. Well, you could use an estimated, how can I say, an estimated variable to production and profits, maybe to try to understand how the territories can change. But in economics, we have the problem, or that is innate to the economic science, that is the unpredictability. Well, we can maybe estimate several models, but we are not sure, 100% sure that those models will be the correct representation. So the most, not to say the most, but the most accurate way we could do that is by estimating several occurrences, which from a point of view of computational power, it's quite difficult. But to answer shortly the question, it is possible, although it's very challenging.
Yeah. That reminds me, that reminds me about urban growth models. There is economic models, such French one, NEDUM or something like that. So that will be maybe helpful.
Sure.
Yeah.
It would be possible to integrate them, but I repeat, you still have to consider the component of uncertainty. It's but it's a nice development that could be made.
Yeah, thank you.
Thank you, Akba.
Is there any other question from you? From some of you?
I have a question.
Hannah,
Sure.
Please.
I would like to know if you consider the different types of industries and as a factor to where they are located you know, different types of industries have different patterns in how they
Yes,
locate.
yes.
I don't know if you consider or if you plan on considering it.
Yeah, in this case, in this specific case of the work, we didn't consider because we analyzed just film size and not making a distinction by typologies. Yet, it is first a limitation of this work, and second, an how can I say a future development. Because we are working just to establish a sort of territorial image of the Tuscany region that considers the particularities of each how can I say, or industrial district or industrial typology. But yes, for this work specifically, we didn't arrive at this point.
Thank you. Thank you.
Thank you.
If you agree, I'm going forward, and the next presentation is entitled Modeling Spatial Centrality of the Logistics Activities Study in the Porto Alegre Metropolitan Region, Brazil. And the authors here are Clarice Maraskin, Ana Luisa Maffini Machado, Renato Maciel Damiani, excuse my pronunciation, of course, all from the Federal University of Rio Grande do Sul. I see here Ana Luisa Maffini Machado. Please, I invite you to make your presentation. Can you please?
I think I'm gonna play the record
Okay.
because I have construction
You want
upstairs.
to share your screen?
I have to screen share with audio, right?
Is the
Yes, it seems working.
Okay,
Thank you very
working.
much. You're welcome. Yeah. I'm sorry. We can't hear.
We can't hear you.
We can't hear you. Please check your microphone.
It's muted. It's muted. No, it's the volume is on the player is.
Okay, you can hear me, right? You can hear the audio.
Well, we can't hear the audio of the recording, but we
Okay,
saw
so
that the volume was turned all down.
I can present live. Let's just hope the construction.
Okay, no problem.
Wild here.
Okay, fine.
Okay.
Can you see the slides now, and can you hear me?
Sure, sure.
Wonderful.
Okay. So, oh, come on. Good afternoon. My name is Ana Luisa Maffini, and I'm a doctoral student at the Federal University of Rio Grande do Sul in urban and regional planning. And I'll be presenting the work modeling spatial centrality of logistics activities, studying the Porto Alegre metropolitan region, Brazil. So I start by bringing an overview of the subject. There is an expansion of the logistics company sector, and it generates economic development through the increase in job offers and tax revenue. And at the same time, this expansion generates spatial impacts, such as the urban expansion into suburban and rural areas, and the attraction of new residential projects, the increase in traffic pollution, among other impacts. Then this expansion becomes a concern for urban and regional planning. And in Brazil, there are a few studies that address the issue, and the ones that do exist, they are on a macro scale at the national level. So in view of these issues, this work aims to present a methodology to analyze the spatial distribution of logistical activities that is based on urban configurational models. So we'll be analyzing the centrality of logistical activities. And the other object is to apply this methodology in the metropolitan region, in the metropolitan region of Porto Alegre. I'm sorry, my cat is trying to destroy my computer here.
No problem.
So in here we have on the left side, Brazil. It's playing. I don't know why it's playing in the video, but Okay, we have on the left side Brazil, and on the southernmost portion, the state of Rio Grande do Sul. The metropolitan region is made up of 34 municipalities, and the state capital is Porto Alegre. This map shows the population density, and in here we can see the capital and the densest axis. We also highlighted the main highways of the region. With that being said, the questions we seek to answer are how the centrality of logistical activities is spatially distributed and whether there is concentration or decentralization. In here, briefly bring up some of the theories of location of logistical activities whose demands lie between those of industry and services. There are two main forces, the centripetal forces that tend towards agglomeration and the centrifugal forces that tend to disperse these activities. Several factors are involved in this, from land price, market demand, accessibility, agglomeration advantages, tax incentives, among others, and all these factors act at different scales and can change over time. And then we have the configurational models. I'm sorry, the slides are going on their own here. And then we have the configurational models that treat the regional system as a spatial network, and the network generates spatial differentiation or a regional hierarchy. The network itself embeds a spatial differentiation that helps to create the hierarchy. So configurational models, they use metrics originated in graph theory, and the measure we used was centrality, which was formulated in 1970s by Freeman, who conceptualized centrality as the relative importance of spaces in shortest paths. In the 1990s, Kraft made an adaptation of this measure, which was then called the Freemancraft centrality, and it is the relative importance of spaces in the shortest path, however, weighted by the length of the shortest path. So we understand then that the logistical centrality is a Freemancraft centrality weighted by the number of the logistical activities in each space. It is a systemic measure, the construction. It is a systemic measure because it considers both the location advantages and firm concentration. So for the data method, we have here the location of the logistics companies. The database we used was from the Ministry of Labor. And for the spatial base, we worked with a simplified base of segments. Initially, we started with the OpenStreetMaps method, and is it too hard to listen?
No, it's good. You can go on. We understand.
If it gets too impossible, please let me know.
No, there's no problem.
So we started with the OpenStreetMaps method, and we used Young's method to simplify and reduce the network of segments in 2 rounds. So in the end, we were left with 3,111 segments, counting with a buffer to avoid the edge effect. So in here we have the summary of the modeling process. We had the spatial base that we showed, plus the logistical activities data that was weighted by the number of employees of each firm. And this was then worked within a GIS environment where the plugin Gauss was used to calculate the configurational measures. And Gauss is a configurational plugin in QGIS, and it was developed by a research group. We then calculated the weighted Freemancraft centrality, generating maps and tables for analysis. So for results and discussions, I bring here then a brief contextualization of the logistics sector in the metropolitan region. We have the 34 municipalities and the variation in concentration between 2005 and 2019. And the red dots, they represent the percentage of the variation between those years. What we noticed here was that companies are concentrated in a few cities, and the capital, Porto Alegre, is the one that stands out the most. However, we can observe that it lost companies in this period, almost 25%. So we have already detected a decentralization process taking place here. Here are the results of the Freemancraft centrality measure. which considers the network, the shortest path, and the number of employees of each company. What we can see is that there are a few highways concentrating the main values, especially highways 116, 290, and 386. In this graph, we can see the values of aggregated centrality in each municipality. And on the right side, for discussion purpose, we have the number of employees. With this, we can understand how employees and the network are each influencing the measure and observe the relationship of the municipalities with better or worse performance in centrality. For example, Novo Hamburgo is a city that has higher percentage of employees than the centrality measure. And what it means is that it has a bad location in the network. Triunfo has a small centrality but a high concentration of employees because of the petrochemical complex that locates in the city. Thus, we can state that we have identified a process of decentralization of logistical activities in relation to the capital. Only 30% of the centrality is captured by the capital. A polycentric pattern was also confirmed, which is a decentralization concentrated in some areas and not a generalized dispersed pattern. There is decentralization in some specific areas and corridors. Also, the location of logistical activities tend to be close to the cities that are the main consumer markets, but outside of it to seek larger and lower cost areas. So for the conclusions, we bring some potentialities of the methodology. The weighted models bring together spatial aspects and functional attributes. It is a flexible model that can be applied to analyze other types of economic activities, and it serves to build simulation scenarios. One of the limitations is the difficulty with the establishment's database, which is provided only by zip code, and this led to the simplification of the urban network due to the data being more aggregated. For future studies, then we seek to include other networks, such as the rail network, the river transports. We will also like to consider different periods of time to see how the network evolves and to explore intermediate scales varying the metric radius in the model. So with that, I conclude the presentation. Thank you very much, and I'm really sorry about the construction.
Oh, don't worry.
Thank you very much, Anna. Nice presentation, nice research indeed. Is there any question to Anna from you, from Safia, or from Okba, or from Diego?
Well, for me, myself, I have a quite number of questions. Having read your paper, I have several points that I would like to address. I hope these points are answerable in the sense that you can address them. So first, I have a question about the measure, the Freemancraft measure. I read in the paper that they are weighted, and correct me if I am wrong, and have certain concepts of tension and dissipation. I would like to an explanation of these two concepts, because it's a quite different measure that we are used to see. And in what way this centrality distribution, the distribution of centralities that you arrive with this distribution is different from a normalization, as for example, the normalized angular choice in space syntax. Because, correct me if I am mistaken, the FK measure seems to also portray the inner hierarchies in between the centrality. So I would like that you address a little better these arguments. I hope it's not a very difficult question.
I'll do my best.
Okay. It's a very complex question, but
yeah, the Freemancraft centrality, it tries to identify the paths of the network that appears the most in the shortest path. And the biggest difference with the spatial syntax measures is that it's weighted by the length of the shortest path. So you dissipate this value through all the network.
Ah, so, okay, sorry to interrupt. So, this dissipation, it's, how can I say, is an equivalent to the quantity of nodes that you have in that length.
Yeah. Yes,
Okay,
and this
okay, I
was
understood.
the quantity of nodes because we use the topological
Okay,
measure, but you could also weight by the geometrical distances.
okay.
Yeah. And it is weighted because the tension between the pairs, we are, I'm sorry, in the plugin, we are capable of weighting, adding like a quantity value, and in this case was the number of employees in the firms.
Okay, I understood.
Because we wanted to be able to capture the difference between having like an Amazon logistics company and having just one employee. So
Okay.
Okay.
I don't know if that answered the.
Oh, thank you, thank you. You're being very clear
Yes.
and answering the question. Is there any other question, or I think we may go on because
Sure,
I
because
would
of the
like to
time.
leave time enough for the others. Thank you once more, Anna.
Thank you.
And the next presentation is entitled Form, Function, and Acoustics, Productive Assets Placement and Relationship Between the Urban Soundscape Patterns and Configuration. The authors are Ukba Bonamour from the University of Mostaganem, Diego Altafini, once more, and myself. Ukba, can you take your microphone and can you share your screen?
Okay, I will try. I wish
Thank
that
you.
will work.
Okay.
Is there any problem with you, Ukba?
No,
I'm trying.
Thank you.
Please.
It's clear now. Thank you.
Okay, can you see it now?
it's loading, but I think we can.
Does it work now?
We are seeing just the black screen.
Black screen.
Oh,
Some few seconds ago
yeah, we'll try
we
now.
had your screen.
Mhm.
I think you'd better share the whole screen and
Does
not
it work now?
on black screen.
Still a black screen.
Wow. I don't know how.
No, so magari sì.
I think it's better for you to share the whole screen.
The whole screen instead of the program screen.
Okay, I will try again.
Let's try. I think
Yes, now we can
I
see.
think,
We can see it.
Okay, that's good.
Yeah, once more. Yes.
Ouch.
Okay.
Perfect.
Now it's fine. Thank you.
Okay, that's good.
You're welcome.
So, hello, everyone. So our presentation is entitled Form, Function, and Acoustics, Productive Assets Placement and Relationship Between the Urban Soundscape Patterns and Configurations. So from the environmental acoustics to soundscape design. So many parameters are integrated to analyze acoustic environmental, such as spatial, social, and psychological. Computational methods, several computational methods were developed and to analyze and to treat this problem of noise pollution, taking into account road traffic, building attributes, and even weather conditions. So many parameters related to urban density and form, such as porosity, permeability, compactness, occupation, and fractal indexes are involved. So taking the study case of Tuscany region, so here we talk about the landscape change and their effects on acoustical environments. It is to mention here that this region is, there is some action plans for the acoustic analysis. So the main objective here is to improve and update those plans according to the landscape changes. So as I mentioned, the main objectives, first of all, is having an overview of the computational methods literature related to urban soundscape. The second is to unearth relations between urban design, movement dynamics, and noise pollution. And finally, highlighting soundscape patterns of the built environment in 6 provinces of the Tuscany region. So talking about the computational urban acoustics, so there is 3 methods. So there is the acoustic wave equation methods, there is the geometrical acoustics methods, and some studies so used both. So that's what we call hybrid methods. So those computational urban acoustics are divided into boundary element methods, digital waveguide mesh, discontinuous Galerkin, equivalent source method, and finite differences time domain, finite element method, lattice Boltzmann method, parabolic equations, pseudo-spectral time domain, and waveguide web. The main objectives of those computational methods treats some issues such as noise barrier, vibroacoustics, street shape, effects of wind, of vegetation, and all that stuff. It is essential too that those computational methods were used in the micro and in the macro scale. So it depends on the objectives of each study. GIS also had a potential in this issue. So we find so many field of applications on transportation, on urban, on regional plannings, and on cartography. So here the purpose is to model acoustic maps, or sometimes to predict sound, analyze the vehicle traffic, because the vehicle traffic is the main source, is almost the main source of noise pollution. And of course, there is so many innovative plugins to deal with this problem. Help address the parameters related to the design of buildings, such as type and height of buildings. And sometimes the GIS is combined with learning machines and human interactions, given the example of urban 3D. So the methodological approach here is we use GIS, we use the free, the open source software QGIS. First of all, to prepare the geometry, we choose 6 provinces of Firenze and Prato. The second step is to collect the infrastructural data, so building structures, road circulation networks, and then we will analyze this area using space syntax angular analysis according to normalized angular integration, which Yes.
Bar, are you there?
Okay.
Oh, thank you.
Oh, I saw here there's a bit instability on the network.
Yeah. Okay.
Can
may
you
go on
hear
now.
me?
Yeah,
Yes,
yeah.
yes.
Fine.
It's fine.
Okay. So, as I said, so about the methodological approach, so I said that the first step were to prepare the geometry of the 6 provinces chosen for this case study. So those provinces are located in Firenze and in Prato. Second step is to collect the data, the infrastructural data about the building structures and the road circulation network. Third step is to analyze or have an topological analysis of using space syntax angular analysis according to normalized angular integration, which refer to accessibility, and normalized angular choice, which refer to the preferential roads. And then we used for the acoustic analysis, the municipal acoustic classification plans. So there is a PCCA plan for the whole region of Tuscany. So we try to use this as support in order to correlate all the parameters of building structures, road network, and then values of space syntax, and then with the acoustic environment of this region. So the study case area is 373.34 kilometers square. The provinces chosen are Calenzano, Campi Bisenzio, Firenze, Sesto Fiorentino, Siena, and Prato. The main functions of this region is touristic and industrial, especially around the region of Prato. So here talking the results of this study. So we noticed such a compact form of the whole region. We noticed that industrial buildings had an orthogonal road network, while the residential buildings had a radial road grid. For the noise classifications, so the class 3 and 6 for the conurbation extension, class 2 for Firenze and Prato suburbs, and class 1 for non-urbanized area, and especially in this region on the mountain that exists around the region of Prato, I think. So the dominant compact urban fabric has a noisy character, residential and mixed uses. So we noticed that there is a class 3 and class 4 for this urban fabric. The industrial build is included in class 5 and class 6, especially in Prato, where industrial buildings are located. For class 1 is isolated on rural between Calenzano and Prato. What we noticed from those results, so I don't know, sorry that I don't have the whole informations because I just wrote them on comments, so percentages, but we can notice that the residential is how to say, is the type of buildings with the highest noisy class, while the second is the unidentified, so unidentified regions. Third is the industrial, because there is some high noise classes, so this is the 0.6% of class 6. It's almost located on industrial, while other functions such as military and cultural, so there is there is a low noisy character. So we noticed from the road network that there is a dense road network. especially around the urban highways, which are classified between 4 and 5. Vehicle traffic represents the main noise sources. So from this figure, we can notice that the vehicle traffic presents the main noise source in the whole region. Now arriving to space syntax parameters or measures. So here the integration values. So taking the figure B. So the figure B shows the highest values of integration, which are located in each province centers. So that's the place where the main activities and are present. While, as we mentioned for the road network, so it's almost the same results for the notch or for the Nash, sorry, or the choice. So where the main highways, so or the nosy one. And then we try to correlate both. So we try to correlate all the variables, and the results given that a high percent, so it's about 88% of class 4 belongs to the highest values of 9 and the Nash. Of course, the 9 are explained by the accessibility, the activities, especially in the region of Firenze here, while class we notice low values on class 5 and class 6, which belongs to the industrial area of Prato. So as a conclusion, we noticed a considerable impact of the form function and spatial configuration on the acoustic environment. Vehicle traffic and pedestrians motivated by tourism and commercial activities are the main source of noise pollution in Firenze city center. Productive activities and vehicle traffics are the main sources of noise pollution in the metropolitan area, where the highest noise classes were concentrated at the city of Prato. Highest values of global measures of angular segment analysis have the ability to provide a clear overview of the acoustic phenomenon. And finally, the relation between movement potentials, the background, and the build structures, the foreground, can serve as a helpful planning instrument for updating the municipal acoustic classification plan. And thank you for your attention. I'm sorry because I had no comment, because that's where I wrote the main results.
No problem, dear Okba. Fine, thank you. We thank you.
Thank you.
Thank you. Do you have a question to Okba on this interesting presentation? Anna, Safia, Diego, do you have?
I have a small, just a small curiosity. I would like to ask you, but if you plan to apply these methodologies that we more like developed together to a context in Algeria, example the Biskra region. I don't know if there is data available to do such analysis, but it would be interesting to compare different cities with different urban forms, but with similar functions, and see how these behave regarding the soundscape.
Yes, thank you. It's a very good question. We already, I would like to mention that we already worked on a comparison about two different contexts with the Professor Coutini. So for the internoise conference, so we tried to compare different regions. So we as an example with the urban context of Pisa. So we had something like that. And for the first question about the data, yes, that's a big problem. That's a big problem, especially.
I understand. Oh, but it's just to see more or less where you wanted to turn it, to go with your work.
Oh, thank you very much. And let's go now to the last presentation of this very interesting session. And the title is Syntactic Study of the Correlation between Urban Spatial Configuration and Use of Streets in the City of Béjaïa. The authors are Safia Mahfoud and Yassin Badat. And Safia, please, you are welcome. You may go on. Please share your screen. Unmute your microphone. I see it muted. Yeah, now that's fine. I think. Try speaking. No, we can't hear. We can't hear. Now, try. Try to say some words, please. No,
we don't hear you.
Provate a chiederle di fare il refresh della pagina.
Sì.
Could you please refresh the page?
It's the sheet, right?
And, yeah, and now unmuted. Click unmute. Yeah, fine. Try to.
Try to click under, Safia, where you have the camera and the microphone, because it's muted there.
In the bottom of your screen, I think. Oh, please, there is a problem with your microphone.
She's trying, I guess, to reload the page.
Se non sta usando Chrome potrebbe essere anche quello.
Sì, uso il Chrome. Se no, casomai mettiamo la presentazione noi.
Ce l'abbiamo?
Sì, ce l'abbiamo qui.
Are you hearing me like this?
Oh, that's fine.
Perfect.
Okay.
Okay.
Okay, please share your screen.
Okay.
Abbiamo altre sessioni dopo? Abbiamo altre sessioni dopo?
No, c'è la plenaria. C'è la plenaria.
Solo la plenaria.
La plenaria è stata prima. Prima di
quella delle 16:30?
Sì, adesso c'è il 16:30, c'è un'altra.
Ma qui?
Sessione parallele, sì.
Quindi.
Please, can you share it?
I don't know. There is a problem.
So we cannot see the screen share. Allora, cascato
Andata via? Dov'è? Uscita fuori?
Uscita fuori.
Se avete il video magari provate a... Cioè mettiamo il video.
Sì.
Si salta magari la sessione di domande nel caso.
Sì.
E
magari saltiamo la sessione di domande.
Sì. No, certo, quello...
Perché purtroppo è il...
Facciamo così quindi. Safia,
can you succeeded in joining the screen? If you can't succeed,
I can't accede to share the screen.
So we will use the plan B. We will share your presentation that you pre-recorded to us, and we'll contact you to answer the questions after. It can be because we are a bit short on time.
Okay, I'm so sorry.
No, don't worry.
It's not a problem. Let's go with the presentation now, please.
So.
Hello everyone. I am very delighted to have the chance to participate in this talk.
Sì.
Yeah.
Sì.
Volume.
Ma l'ho messo proprio in questa. Ho messo proprio in questa.
Okay. That's fine.
Okay.
Just a minute.
If you can turn up a little bit the volume, I don't know.
Hello everyone. I am very delighted to have the chance to participate in this conference. I am Ms. Safia Mahfoud, a PhD student Accra in Nigeria, and I will present you a work entitled Syntactic Study of the Correlation between Urban Spatial Configuration and the Use of Streets in the City of Bejaia under supervision of Professor Yasin Badr. As introduction, we can say that the city is a cordoned whole with a structure and the meaning, and streets play a very important role in its functioning and represent its framework. Some cities, such as Bejaia, which is a Mediterranean city located in the northeast of Algeria, 250 kilometers east of the capital Algiers, are facing many problems, such as the disparities in the use of streets between different parts of the city. The questions which then arise are the following. What are the causes of these disparities in use between the streets of the different parts of the city of Bejaia? And what is the impact of the resulting consequences on the function of the city and on urban life within it? The present work aims to investigate the correlation between the spatial configuration of the city of Bejaia and the use of its streets. The term spatial configuration refers to the structure accommodating movement dynamics under Unicode results, and which is determined by the presence of boundaries between different areas and the connection and disconnection of these spaces. The investigation implemented is then based on space syntax as a theory and analysis approach using depth map software. The concept on which this work is based are as follows: spatial configuration, use, street, space syntax, and depth map software. And in order to investigate the questions posed and to be able to make a comparison, the city of Bejaia was divided into zones using the criterion of location. With this in consideration, 3 different zones were chosen for the study. A housing zone, the zone of Sidi Ahmed, as a new urban residential zone, Zone 1, characterized by a network of winding streets, which are mostly secondary roads used by the area's inhabitants. The Old City and Plain, OCP, a heritage zone with mixed-use function, Zone 2, characterized by a distinct morphology, with a historical center that comprised by a series of irregular streets with mixed use, while the plain expansions possess a more regular morphology. And finally, the Bejaia industrial zone, BIZ, Zone 3, instead is entirely regular, possessing a usual orthogonal grid morphology. From these 3 areas is highlighted a street path, the Sept Street, that establishes the linkage between zones and which is considered to be a very important axis of transport in Bejaia. The methodology for analyzing these areas consists of the use of 2 quantitative methods. The first method consists of the in-situ observation with pedestrian counting, gate count, made on weekdays and weekends. As for the second, it is the syntactic analysis concretized on 2 scales. At the scale of the 3 zones macro, to capture the connectivity of the spatial configuration of the city, combining the street network and urban entities, and this by relying on an actual analysis to estimate intelligibility and synergy correlations, and on an actual segment 1 to assess normalized angular integration. And at the scale of the street crossing the 3 zones micro, and this to compare its syntactic properties with its capacities of use resulting from behavioral analysis with the creation of an actual segment map to measure normalized angular choice and integration and their combination. Finally, the result of these 2 methods will be overlapped. The result of the in-situ observation and the gate count method show that the aggregate number of people crossing the control gates is 6,670. The zone 2 that comprise the Old City and Plain area recorded the highest number of people, followed by the Zone 1, the Zoo, and then the Zone 3, the industrial zone. These results are in accordance with the expected minimum, since the Zone 2 possesses the greater number of functional attractors, commerce and services when compared to the other zones. From the syntactic and action analysis of the three studied zones taken together, made at the macro scale, it can be noticed from the scattered diagrams that the reading of the urban space is not easily done and that movements are made with some difficulty, and this according to the value of intelligibility, which is lower than 0.5. Here we have 0.25, while the local structure is not linked to the global level according to the synergy value, which is upper than 0.5. Here we have the synergy equal to 0.58. The actual segment map established at the same scale demonstrates that on global scale, the part of the street located at the level of zone 2, called city and plain, is the most integrated with a value of 0.021, revealing a good correspondence with the movement. The zone 3 presents a value of 0.016 and represents the industrial zone where pedestrian movement is uncommon, thus explaining the lower values for gate count. Mean values of 0.010 are fine for the zone 1, zone, which are the lowest from the three areas at a global level. All zones comprise the analyzed street demonstrate mean values lower than the historical center area comprehending the orange city zone 2. On the scale of the orange street crossing the three zones, and for the combination of the two measures of normalized angular thrust and integration to better reveal the movement, the results show that the parts of the street located at zones 1 and 3, the zone and the industrial zone respectively, come in first position with a value of these two combined measures of 0.020, then come the part of the street situated in zone 2, the OCP, with a value of 0.018. According to this result, it seems that the parts of the street located in zones 1 and 3 are the most used and easily capture pedestrian flows, but in fact it is not. By superimposing all the results for each zone and which are not in compliance with space syntax theory, we note that the good use of the street at the level of zone 2, the OCP, despite its low local syntactic properties compared to the two other zones, as well as the low use of the same street at zone 3, the industrial zone, despite its good local syntactic properties, this can be related to global syntactic properties such as global integration, or to functional ones such as the renewed invocation of the zone, since zone 2 is a zone with a functional mixing, while zone 3 is an industrial one. To conclude, we can say that the examples and use of the streets in the city of Virginia depend on the one hand on the global syntactic properties such as the configuration of the urban spatial structure and the good integration of these streets within the whole city. On the other hand, functional properties also play a very important role in the use of streets, such as the urban location of the area where they are located, the land use pattern, and the activities and services present at their walls. These activities have a multiplier effect on the attractiveness of streets and participate in urban life, thus affecting the proper functioning of the city of Virginia. The limit of this research, as it is still ongoing, needs more in-situ observation work to be done over various times and the gate count stations to have conclusive results. At the end of this presentation, I would like to thank you for your attention and I am at your disposal for any questions. Thank you.
Thank you, Safia. Unfortunately, we have no time enough for an extended discussion of your interesting presentation, but I'd like to ask you if you are planning to make a configurational assessment of the whole city.
I'm sorry for the problem.
Including the coastal and the older residential areas that were left out of the study. Safia, are you there?
I think its network is very bad. The problem of connection.
Safia, can you hear me?
Yes. For the moment, I have a land use of the city, but it isn't complete.
Okay. Thank you.
Thank you, Safia. I understand.
Thank you, Safia, and congratulations for your nice presentation. Sorry for the problems with the connection, and I thank you all for your presence here, and I hope...
Yes, I just complete the land use map of the city of Jaya to do deep operational analysis.
Okay, Safia.
Yes, I'm here.
No, because we hear with a bit of interference.
Thank you very
But
much.
thank you very much.
Thank you, Anna. Thank you, Okba. Thank you, Safia. Thank you, my dear Diego. It was nice being with you. Hopefully, I look forward to seeing you personally, physically, in another opportunity to meet you. Goodbye. Thank you.
Goodbye. Thank you.
Okay, thank you.
Okay.
Thank you. We close the session. Okay. So, Professor Polino is here.
Good afternoon. Yes, I'm here.
Good afternoon. I'm Raffaele, your room assistant today. I apologize, we had a few minutes of delay, but if you want, we can start right now.
Okay. Just to solve any possible technical issue, can you hear me properly?
Yeah.
The mic is okay? Okay. Before to start the session, I would ask if are present all the colleagues which will make their presentation for the contribution scheduled. For the first one, two-stage CNN-based wood log recognition. Is there anyone?
Yeah, I'm here. I'm on site.
Okay, okay, perfect. For the second, I see Francesco Solano. Okay.
Yeah.
Okay, hi Francesco. Gian Domenico De Luca.
I'm here.
Okay. Yes. Hi Gian Domenico. Hi. And Stefano Chiappini for the last presentation.
No, it's me, Mattia Balestra.
Mattia Balestra. Okay, okay.
I'm here.
I will modify. I'm going to modify the presenter. Okay. So I guess that we are ready to start. So when Raffaele will give me the red light, the green light, I will start. Sorry, Raffaele, can we start?
Just a second, we are trying to copy
I'm just sharing my screen just to allow to see a slide with the authors and the titles of the presentation. Can you see it?
Yes, Professor Polino. If you want, we can go on with the second presentation. In the while, I copy the file of Georg in my PC to share this presentation.
Okay.
Okay. Thank you.
Sorry, thanks.
It's a presentation, okay? Professor Polino?
Yes, I'm here.
We are having some problem with the file by Georg. If you want to start with the second presentation,
Okay.
we can make the Georg's presentation.
Okay. Okay.
Okay.
We will flip the first two presentations. So, Francesco, your presentation will be the first.
Yeah. Okay.
Okay. Are you ready?
Yeah, I'm.
Okay.
Share the screen.
Yeah, Francesco, firstly, I am sharing the screen just to show this introductory slide. So
Okay.
I will leave you the floor. So Raffaele, you can start the session also on YouTube.
We are already online, so we can start when you want.
Okay. Okay. Good afternoon to everybody. My name is Maurizio Bollino, and I am the chair of this session. And on behalf of the other workshop organizer, Professor Giuseppe Modica and Professor Marco Bizzari, welcome to the Geomatics in Agriculture and Forestry workshop. This afternoon, 4 presentations are scheduled in this session. And in this slide, you can see the 4 presentations, the authors and the titles. And so I, just to not spend other time chatting about this introduction, I would prefer to leave the floor to the authors. So the first presentation will be unmanned aerial vehicle derived canopy gaps in the old grove beech forest of Mount Polinello in Italy, preliminary results. The presenter is Francesco Solano from the University of Tuscia, and I leave the floor to Francesco for his presentation. Please, Francesco, you can proceed.
Thank you, Maurizio. Okay, but I'm not able to share the screen. It's okay. Let's try. Okay.
Okay.
Did you see?
Yes.
Okay.
You can see your presentation.
Okay.
Okay.
Good afternoon to everybody. I'm Francesco Solano, and I'm a postdoc researcher at the Department of Agriculture and Forest Science of the University of Tuscia. And now I'm going to present this research carried on with Professor Gianluca Piovesan from the University of Tuscia, jointly with Dr. Salvatore Praticò and Professor Giuseppe Modica from the Rural Working Group of the Agraria Department of the Mediterranean University of Reggio Calabria. This topic is about a particular analysis of forest structure that we know is the result of the interaction between different ecological factors that affect all these dynamics. In this framework, natural disturbance, such as the opening of canopy gaps, are the main drivers and play an important role in maintaining biodiversity and represent the dominant form of forest regeneration because of the continual reshaping of the forest structure. So the analysis of forest canopy gaps in primeval and old-growth forest can provide helpful information on these dynamics, so that disturbance-driven canopy gaps need to be quantified and monitored as long as they configure as an essential reference for delineating a sustainable management approach. So in this framework, remote sensing allows such investigation, being able to map entire landscapes. However, tiny gaps cannot easily be recorded, even with the latest medium resolution satellite imagery, but very high resolution image provided as example by commercial satellites should be used, or LiDAR-based approach that provide more detailed informations. But this limitation can be overcome by UAV's availability, representing a cost-effective solution for usual forest insights. So the main aim of this research was to assess a first canopy gap detection and spatial pattern distribution from a UAV-derived canopy 8 model in an old-growth beech forest placed in the Calabrian side of the Pollino National Park in South Italy. We selected this area for because only the core area of the old-growth forest, as it is a very priority site area, and for its ecosystem integrity, recently joined the UNESCO World Natural Heritage of European cereal sites. So this is our workflow that we adopt for our UAV survived and data acquisition and processing. We use the quadcopter with an integrated RGB camera. The flight was conducted in a semi-automatic mode and was georeferenced using GPS mounted on board the vehicle. Once we acquired the aerial images, the entire photogrammetric process was conducted in Pix4D Mapper Pro software, and we obtained very high resolution orthomosaic at 3 centimeters of spatial resolution. And to estimate forest canopy 8, the vertical difference between the digital surface model and the digital terrain model that we obtained from the photogrammetric process was used to obtain the canopy 8 model. Once we obtain the canopy 8 model, we import it in our environment, and we detect all the canopy gaps present on the canopy 8 model by defining a gap as a contiguous area where the vegetation 8 was minus or equal to a defined 8 threshold, and between a minimum and a maximum gap size. So we set a value of 5 meters as the vegetation 8 threshold and 10 square meters as the minimum gap size. So the algorithm finds this gap on the canopy 8 model pixels, and once we have obtained the boundary of the gaps, we export them as a vector polygon. To assess the validation and accuracy of this process, we use the orthomosaic as a reference layer for manual digitization of the gap boundaries. So in a JS environment, we built a grid over the study area, and then we randomly distributed 11 sample points within the grid, and inside its cell, all the gaps have been manually digitized. So the accuracy was assessed as object-based evaluation by comparing the correctly detected gaps derived from the canopy 8 model with the digitized reference data. And we use the F-score as a measure for the overall accuracy. Moreover, we analyzed the geometrical properties of each gap by calculating some statistics and exploring the perimeter area relationship, and calculating also the shape complexity index as a measure of complexity for the gap shape. We also use a zeta distribution function to quantify the size frequency distribution of forest gap, as it is a discrete power law probability density, and we estimate the exponent lambda. We finally investigate also the spatial pattern of the detected forest gaps with the replay K function and its modification, the L function, with the null hypothesis being a random distribution. Moreover, we evaluate the Clark and Evans aggregation index R to see if the pattern was uniform, clustered, or dispersed. Here are the main results. So the evaluation validation process, we achieve a satisfactory result if compared with other similar studies, with an F-score of 0.94 and a detection rate of the 89%. And the total gap detected accounted for the 10% of the canopy gap fraction referred to the total forest extent. The mean gap area we reached was 64 square meters, and the difference in vegetation age inside the canopy show how the underway renewal process are due to disturbance event differentiated over time. In the figure that you see on your left, the perimeter area relationships show that the gap geometry became more complex with the gap size, and this was confirmed also from the value of the complexity index, that this condition points out the vital role of old-growth forest in conserving biodiversity, as higher value of this index is strictly correlated with the species richness. In the image on the right, you see the gap size frequency distribution that followed a power law distribution with a negative slope. And we reach a lambda value of 9.95, that it's close to the value of 2, meaning that in this forest are present many small gaps. Finally, we can see in this image the observed K function from the spatial distribution that is higher than the expected one for a certain distance. So the distribution is more clustered than randomized. The same pattern was observed considering also the L function on the right of the figure that showed statistically significant dispersion only for smaller distance within 15 meters. The value of the aggregation index R, we obtain 0.81, confirms a cluster aggregation, however suggesting a tendency toward randomness. So these results reflect the possibly patchy recruitment on these particular soils and slopes. Gap clustering at greater distance could be caused by factors related to the site's nature, such as slope or aspect, which may influence the formation of gap in the study area. So the gap pattern was predominantly clustered in this old growth forest. So we showed how the potential reliability of a UAV candidate model based gap extraction procedure. And this, we saw also that the tree mortality and the local stem level disturbance were the principal nature of the gap opening process. At the local scale, the prevalence of small-scale processes highlights that the absence of major or intermediate disturbance, but this is due to the absence of human pressure. In this site, nearly the last 70 years were no human pressures, and because of its remote location. Obviously, further studies will be needed to increase the accuracy of the survey and the methodology adopted to ensure a real-world ground truth, to better understand the ongoing ecological processes. Also establishing a continuous monitoring system of the disturbance dynamics will allow to better reconstruct these processes, allowing the sharing, for example, of the data through the creation and implementation of dedicated web map tools. And the last, and more important, these results, coupled with forest complexity metrics, could then be used to evaluate the forest ecosystem and naturality. And that's it. Thank you for your attention.
Thank you very much, Francesco. I've truly appreciated your presentation, especially for the study area selection, Pollino National Park. I'm joking, of course, but seriously, it is a very interesting activity. And any question from the audience? Well, I just a question about you said that you used the replace K function for gap spatial pattern analysis, and this is typically a point pattern based analysis. So, which kind of data did you use in representing a gap? And in your opinion, different data input can affect the results that you can obtain?
Okay, thank you for the question, Maurizio. As it is an ongoing research, we were first interested to the general type of distribution of gaps. So we used the gap polygon centroid as a point reference, and then we analyzed the spatial pattern. But of course, we are aware that considering a gap as a point location appears unsuitable, because the gap size may be very variable, and the centroid of the gap may be far away from the edge. So for this reason, we are planning now to adopt a polygon-based approach to adequately consider the real irregular shapes and size of gaps. And of course, results should show more detailed spatial pattern information.
Okay. Okay. Perfect. Thank you very much, Francesco. Thank you again. So now we can have the second presentation of this afternoon. Two-stage CNN-based woodlog recognition. If you are ready to share the screen, I leave the floor to the presenter. Georg Wimmer, is it correct?
Georg Wimmer, yes, correct.
Yes. Okay. Georg Wimmer from University of Salzburg. Please, you can start with your presentation.
Okay, hello, my name is Georg Wimmer. Okay, and I want to present the paper, two-stage CNN-based woodlog recognition. Okay, now, okay. The first outline of the presentation. The first thing is the introduction on woodlog tracing based on digital logend images. Then we present the databases. After that, we explain our CNN-based segmentation of the log cross sections. Then the CNN-based log recognition. Then the experimental setup, and finally the results and the discussion. Now first, the idea behind woodlog tracing. So the idea is that at the harvesting, the log cross sections are taken photos of, and once again later at the sawmill. So we can, at the sawmill, you can identify which log that is used now, and so in which wood it was processed and by whom it was processed. And the idea is also it would be With that, it will be possible to combat illegal logging, and it's also an important step for the new industry standard to trace individual logs. And yeah, the advantage of using images is that we don't need physical markings, which are more expensive, of course, and also because takes more time. But in this work, we will not have the log tracing from the wood to the sawmill, but it's separate on the different databases. So once in the wood database and once later at the sawmill. That's for later work we are working on now. Okay, first we present the first database, the cross-section log database. It's a combination of 3 sub-databases, and the database comprises 2,270 cross-section images from 279 different logs. And for this dataset, we have manually segmented masks available. Yeah, here we see example images for each sub-database. The second database is the 100 logs database. It comprises different datasets, all taken from the same 100 logs, and the images were acquired from both ends of the log. Here we have different subsets. 2 datasets are acquired directly at the forest, one with a Huawei camera and the other one with a Lumix camera. Then the sawmill dataset was captured at the sawmill, and it was captured after cutting off a thin disk from each log end. Then the thin disks that were cut off were once again acquired in a more laboratory conditions under collaborative, and they were acquired once raw. That means with the saw cut pattern and all from the chainsaw cut visible, and once again after the log cross sections were sanded. So here we have a perfect visibility of the tree ring pattern. From each dataset, from the 100 logs space, about 4 images were taken per log side. And for the forest images, there we have heavy raw saw cut pattern, and so the visibility of the tree ring structure is not really good. It's a bit better for the sawmill dataset and for the raw discs, and the tree ring structure, tree ring pattern is perfectly visible for the sanded dataset, for the sanded discs. They are all, the images are taken under different viewpoints, except of the discs, and also all images, also the discs are differently rotated when acquired. For the segmentation, we use a mask as RCNN framework using the ResNet 50 architecture. As training data, we can use the cross-section log dataset, where we have the manually segmented masks. And also the nets are trained. The trained nets are then applied to the 100 logs database to get also segmentation marks for this dataset. And in case of the cross-section log dataset, we also want automated segmentations. So here we apply a 4-fold cross-validation. We see here the process in the images. So first the segmentation, then the background is set to black. And then the smallest possible square size image is cut out so that the full cross-section is still fully visible inside of the patch. Here we see some examples for the segmentation outcome. In general, the segmentation worked perfectly well for the sawmill dataset and for the 2 disks datasets. For the forest datasets, it worked also for most images quite fine, but for some images, there are slight segmentation errors. For example, here, some parts of the cross-section of the log were labeled as background, and for image F, it's the other way. For the wood log recognition, we use a CNN triplet loss. The triplet loss requires 3 input images at once. 2 images are from the same class, so the same log, and another one is from a different log. Here we see the scheme in the image.
So first the images are fed through the network, then an embedding is produced. This is the embeddings are then fed through the triplet loss. And so the CNNs are trained in a way so that the Euclidean distance between the CNN outputs of two images from the same log are small, and the distances between images of different logs are big. And the big advantage of the CNN triplet loss is, compared to other CNN losses like the softmax loss, for the softmax loss, you can only classify images with which you have trained with the same classes. That doesn't apply for the triplet loss. So for the CNN training, we use a hard triplet selection. That means we only use these triplets that really improve the net. And with net architecture, we use the squeeze net. And the last layer of the squeeze net is changed so that it produces a 256-dimensional output vector. And we also apply data augmentation. We do random rotations to make the CNN more invariant to rotations, and also random cropping. So we apply a fourfold cross-validation on each dataset separately. Then we have to say that so one fold consists of 1/4 of the logs, so images of all the images of 1/4 of the logs, and in the first experiment we additionally use training data from logs of other database. That means if we apply the experiments to the cross-section log database, we additionally use training data from the 100 logs database and the other way around. So more training data is always fine for CNNs. And as performance measure, we report the equal error rate. Then we compare our approach with comparison methods from previous works, the 2 iris-based methods and 1 fingerprint-based method. Okay, here we see the results. In the first rows, we see the CNN results, and in the bottom rows, the results from the comparison methods. When we compare the results, we can see that the CNNs clearly outperform the comparison methods, especially at the 100 logs database. We can also observe that using additional training data slightly improves the results, like with CNNs, more data nearly always helps to improve the results. For the cross-section log database, we have the results for the manually extracted segmentations and also for the CNN segmentations. We can see here for the CNN that the results only deteriorate very slightly when using the CNN segmentation, but for the comparison methods, the results become clearly worse using the CNN segmentation. Okay, so now the results and discussion. So the main finding is that the CNN-based approaches are clearly superior to the traditional ones. The additional training data improved the results. Also, the additional data is from another database with different image acquisition condition and a different camera. And the cross-section segmentation works better for the CNN recognition, and the comparison approaches had more problems with maybe small errors in the segmentation. Yeah, and one other finding is the results on the forest datasets are better than for the sended disk. For the sended disk, we had ideal acquisition conditions, same viewpoint, only different rotations. For the forest datasets, we had raw saw-cut pattern and different viewpoints. And so that means that the saw-cut pattern works well as feature for CNN recognition. In this case, where we make the experiments on X database separately, but in case when we use it in a practical case, when we trace from the wood to the sawmill, this will be a bigger problem. And it also saw it in a new paper that we write now. There's a much bigger problem because the saw-cut pattern is, at least we had for this data where the chains are cut, it's very intense and there's not many information of the tree-ring pattern left. So that will be a problem for the real application case then. Yeah. Thank you. Are there any questions?
Okay. Thank you, Georg, for your presentation. Very interesting. And of course, if any questions from the audience, if we have any questions, please. Otherwise, I will make a question, which is just... there is a question from Ernesto. Please, Ernesto.
Hi, hello. Thank you for your interesting presentation. Very nice. We are not expert, but there's a little clue from my young fellow, but they are too shy for asking and raise their hand. So I will make the question for you. Is about the process of manually creation of the masks. And is it a limit in your approach? Because I think it's time consuming. Could you give us a couple of words more on that?
The training was time consuming, but okay, in a practical application, we have already a trained net, then the evaluation is very fast with the CNN, so that shouldn't be a problem. So,
okay.
Yeah.
Okay.
Thank you.
Okay. Thank you, Ernesto. Thank you, Georg, for this rapid question and answer. Just a curiosity from my side about the image acquisition. I'm wondering if external factors such as exposure, contrast, can affect your procedure or are not relevant for the subsequent recognition phase?
The contrast and things like that. Yeah, the databases, the images of one log were acquired with only a short time delay between each other. So in these databases, there's not much difference of a lightning or something. So in a real case scenario, it would be much harder because maybe it's the morning in the forest with another lightning condition, and later the sawmill may have total different ones.
Okay.
Yeah.
Clear. It's clear. Thank you. Okay. Thank you again for your presentation. Any other question? Okay. We can proceed with the third presentation, combined use of Sentinel-1 and Sentinel-2 for barn severity mapping in a Mediterranean region. The presenter is Gian Domenico De Luca from the Mediterranean of Reggio Calabria. So Gian Domenico, please, I'm leaving the floor to you for the presentation. You can share your screen.
Good afternoon. Yes, I'm going to share the screen. Okay. Let me know if you can see the...
Yes, it's fine. Okay.
So, good afternoon. I'm Gian Domenico De Luca, PhD student of University of Reggio Calabria, and I'm going to present you a work based on barn severity estimation and mapping, and using SAR and optical data and open source processing solutions. Barn severity, defined as the degree of environment, chemical and physical change and the composition of organic matter caused by fire, determines microclimatic and ecological changes at different spatial and temporal scales that could rearrange the habitat assets positively, inducing regeneration or regrowth, or negatively inducing degradation, desertification, and other problems. For these reasons, the spatial distribution of the barn severity is a crucial and essential step for assessing and monitoring the fire impact on ecosystem, and moreover addressing optimal and timely post-fire management operation. In this framework, satellite remote sensing techniques demonstrated to be very effective. High correlation, in fact, has been found between some specific spectral band and field-based severity measurements, in particular with the infrared optical domain. On the other hand, also active synthetic aperture radar have also been explored in recent years for band severity, reaching efficient results. The use was also encouraged by the availability of open source data acquired from satellite sensor with increasing spatial and temporal resolution. In fact, in this context, for example, very relevant was the launch of Sentinel Constellation, the Copernicus mission, managed by the European Space Agency, providing free high temporal and spatial resolution data. In particular, the Sentinel-1 that provides our SAR C-band sensor, and the Sentinel-2, the multispectral sensor of Sentinel mission. However, few studies have tested and compared the results of the combined use of Sentinel-1 and Sentinel-2 for band severity purposes. For this reason, this study aimed to evaluate the capability of the integrated use of Sentinel-1 and Sentinel-2 to estimate band severity in an heterogeneous Mediterranean environment. Machine learning models were performed for this purpose using the field-based measurements as training data. The fire event occurred in August from the 3rd to the 10th of 2018, covering around 269 square kilometers. The study area was located in the Serra de Monchique mountain range in Algarve, the southern part of Portugal. The site was covered by typical Mediterranean vegetation. For example, the forest areas were composed mainly by coniferous, broad-leaved trees, for example, Quercus suber, and the eucalyptus plantations. A large part of the territory was covered by sclerophyllus and shrublands or pastures. The band severity was quantified applying the composite bar index protocol on the basis of a visual interpretation of the georeferenced photos. It was also supported by the high-resolution S3 ArcGIS world imagery and by the field notes taken during the on-field surveys. Concerning the composite bar index, K. Besson proposed this index for determining the bar severity, becoming now a standard metric in literature. This index is based on the qualitative and quantitative measurements of ecosystem alteration by visual comparison of the above-ground biomass and necromass condition between pre-fire condition, the condition pre-fire and post-fire. In the CBE protocol, several ecological attributes were measured in 5 vertical structural layers or stratums. For example, the degree of cover, the degree of foliage altered, or percentage of unburdened vegetation, and so on. 6 fire severity categories were created at the end. The first 2 that concerned the unburned surface, unburned soil and rock, unburned vegetation, and the other one concerned the low severity, the moderate severity, moderate high severity, and the high severity showed in the images on the right. Concerning the dataset, 2 different datasets were combined, coming from the 2 different types of sensor, Sentinel-1 and Sentinel-2. The SAR Sentinel-1 time series was composed of 10 images in total, 5 images before the fire, taken before the fire, and 5 after the fire. Including in this for the SAR Sentinel-1, including both the ascending and descending orbits. Concerning the optical Sentinel-2 temporal series, it was composed by 6 images, 3 before the fire and 3 after the fire, covering around 1 month and 1 month before and 1 month after the fire. Concerning the Sentinel-1, a series of pre-processing steps anticipated the severity estimation. So the orbit file application, thermal noise removal, calibration to beta, radiometric terrain flattening and correction. All these typical pre-processing steps were carried out. Subsequently, all the Sentinel-1 images were stacked and a multi-temporal filter was applied to reduce the speckle noise effect. Finally, the backscatter time average was computed separately for post and pre-fire images and for polarization also to improve spectral reduction. Concerning Sentinel-2, since the level 2A was used, the pre-processing included only the pixel resampling to 10 per 10 meter pixel size. Also for optical, the time average for pre- and post-fire period was calculated for each band. From the 4 resulted backscatter time average, 3 dual polarimetric SAR indices were calculated. The radar vegetation index, the dual polarimetric SAR vegetation index, and the radar forest degradation index. Moreover, the difference, so the delta, between pre and post-fire of each index were calculated. Finally, the new delta image and the only post-fire image for each SAR index were used as the SAR part of the final dataset. After that, concerning Sentinel-2 dataset, all the post-fire 10 and 20 meter spatial resolution, the latter was resampled to 10 meters, and their respective pre- and post-fire delta, so difference, were used as optical part of the final input dataset for the next processing. Before that, the two SAR optical dataset were clipped on the same area, were stacked and aligned together. Using a part of ROIS as training data, a supervised pixel-based classification of severity of the 5-6 severity categories was performed by applying the random forest algorithm implemented in the scikit-learn Python library, that is a Python library. 3 different datasets combination were processed separately in order to test the performance, only optical, only SAR, and optical and SAR together. The optimal parameters of the random forest model were determined using an exhaustive grid search approach, based on the testing and the cross-validation of each possible combination of the set of values given for each parameter of the random forest model. The spatial distribution of bar severity are here shown in the image on the left for each of the combination of the dataset combination. So Sentinel-1, Sentinel-2, and Sentinel-1 plus Sentinel-2. Moreover, in the table on the top is reported in the right on the top is reported the resulted surface distribution for each burn severity categories. Meanwhile, in the table on the bottom is reported the accuracy of the maps expressed by the single class and multi-class F-score metrics. To perform the pixel-based accuracy assessment, we used the pixel of the ROIS not used for training, actually. As we can observe, the obtained bar severity maps provided different level of accuracy, while the optical information called already suffice to map burn severity, thanks to the univocal spectral properties that characterize the fire effect. The integration of SAR data, so the use of both types of sensor, leads to better results. Considering the performance of only SAR data, we achieved the worst result, but actually this was expected because in line with what resulted from other studies in literature. Here we can observe the feature importance resulted from only one combination, the Sentinel-1 plus Sentinel-2 combination. In general, the cross-polarization is more influent if compared to the copolarization. This probably because the cross-polarization backscatter is more correlated to the above ground vegetation structure and volume, so is more sensitive to changes in canopic structure. The sensitivity of the near and square bands was confirmed. In fact, these bands are widely used for burn severity mapping and monitoring purpose. However, it is interesting to observe how the red edge, red and blue bands were also fundamental in achieving the results. Some authors had already observed this aspect, so could be very important to to follow the studies on this aspect. In conclusion, this study aimed to assess the potential of integrating SAR data to optical dataset to estimate and map burn severity and contribute to the state of the art. While the C-band SAR data cannot achieve reliable result if it is used alone, the integration of the two types of sensor improved the accuracy of the results. So a more in-depth investigation would be helpful to understand how this data can effectively complete the derived information in base of the vegetation type, of course, type. Future studies could investigate the correlation between severity mapped and forest regeneration projects and spatial partners. So, thanks for the attention.
Okay, thank you, Giandomenico, for your presentation. Nice work, very interesting. And any question from the audience?
Okay, very good.
Meanwhile, I have just a question regarding the last slide about the next developments and the possible future project activities, which apart from the validation phase, the investigation of data and so on, which could be the natural follow-up of this analysis in terms of an actual projectual or working activity?
Oh, thanks for the question. Yes, actually, this was the first step, I think, for the natural continuation of this work could be the analysis, the temporal analysis of the vegetation, of the behavior of the vegetation in consequence of the fire, in base of the severity that here we estimated. So, in function of the vegetation type and the fire severity, we should analyze the temporal profiles, the temporal behavior, and the behavior of the regrowth of vegetation, I think. Yes.
Okay. Thank you, Giandomenico. Any other question? Okay, I think that now we can have the last presentation of this session. A machine learning approach for mapping forest tree species, an application of Google Earth Engine for the study case of Monte Sant'Angelo in central Italy. The presenter is Mattia Balestra from Università Politecnica delle Marche. So, Mattia, please, I'm leaving the floor to you, and you can start by sharing your screen, and then you can show your presentation.
Okay, thank you, Maurizio. Okay. This one. Okay. Okay. Can you see the presentation?
Yes, yes, we can see. It's okay.
Oh. Wait a moment. It's working?
Yes, okay. It's working. Okay. Also,
perfect.
The slide transition.
Okay, thank you. So, good evening to everyone. I'm Mattia Balestra, and firstly, I would like to thank the organization who gave us the opportunity to share our research, which is based on a machine learning approach for mapping forest categories. This is the agenda. After a basic introduction, I will explain why are important those applications and how our research team has carried out this research, and then the results and the conclusion obtained. First of all, a brief introduction about remote sensing, which is the science and the technology by which the characteristics of objects of interest can be identified, measured, and analyzed without direct contact. The sensor mounted on the satellite measured emitter, reflected, or transmitter radiation, And this technology has advantages, such as the reduction of the data collection, accuracy quantification, and expansion of the study area. It creates advantages when used to evaluate the chlorophyll absorption of vegetation and relate it with the healthy status. According to the European directive, such as the Habitat 1, the EU countries have to monitor and survey their own habitats every 6 years, and this commitment can be carried out utilizing remote sensing techniques. In this study, we use a machine learning algorithm called random forest to develop vegetation cover maps, but there are other methods, as mentioned in this slide. This is the location of the study area in central Italy, in the Marche region. It is the Sevia forest. On March, thanks to a field survey, ground truths were collected with a GNSS instrumentation, and we collected 32 points, each of one with defined forest categories. We identified 4 forest categories: the conifer deforestation, the mixed hardwood, the whole oak wood, and the hornostrianian ones. This is the workflow that we used to develop our research. And the first step was the collection of ground truth points, being our study based on a supervised method of classification. Then we create a set of Sentinel-2 satellite images, taking monthly images from 2018 to 2020. The multispectral satellite image allowed to process different vegetation indices. For this work, we analyzed the normalized difference vegetation index, NDVI, the green normalized difference vegetation index, GNDVI, the transformed difference vegetation index, TDVI, and the enhanced vegetation index, EVI. Around the 32 ground truth points, we create a 15-meter radius buffer area. Then we create the time series. We made the principal component analysis to lower the computational data without loss of information. And then we did the random forest as machine learning method of classification. The accuracies obtained were calculated thanks to the confusion matrices. The images acquired by the ESA platform are open access, and the main application include, among other ones, the agriculture, the land system monitoring, and the forest management. These images are captured with a multispectral instrument, which is able to sample 13 spectral bands. The bands we use for the vegetation index calculation at 10 meters of spatial resolution, while as radiometric resolution, they were stored at 16 bits as reflectance. These images are freely available for users, and they include 2 levels of correction. This study has been carried out employing the Google Earth Engine platform, which is a geospatial data storage, analysis, and visualization services powered by the Google Cloud platform, and which is based on the interactive JavaScript through the code editor. The choice to use this platform was made because of its strength points, such as its potential being an open source platform, the lack of necessity of a supercomputer, and wide storage space, because this platform works on cloud. And we have the possibilities to have access to huge georeference dataset and other ones' strength points. Of course, this platform has some weak points, like the necessity to rearrange the existing scripts in order to make them fit in a certain case study, like our case study. And another one is that this platform works differently from other software for statistical computing, such as R or MATLAB, which are more used in the research world. This slide shows an example of output for each vegetation index compute for January 2018, and the relative formula used for their calculation. The NDVI is sensitive to the chlorophyll concentration and gives an idea about the vegetation healthy status. The GNDVI is more sensitive than NDVI to the chlorophyll concentration and is used for assess the moisture content and the nitrogen concentration in the plant leaves. TDVI is less sensitive to the soil optical properties variation and is more suitable for estimating the fraction of vegetation cover in forest and agricultural environment. While heavy is an improvement of the NDVI, and thanks to the correction of the residual atmospheric contamination, and it has an improved sensitivity to vegetation canopy structure variation. As mentioned before in the workflow, we created a 50-meter buffer around each point collected during the field survey, and each pixel's centroid folding within the buffer has been converted into a feature, recording the pixel's absolute coordinates as features properties. Once that we obtained the vegetation indices value of each pixel, we were able to plot them as time series by plot each pixel time pattern as a single random color line during the 12 months, and so creating the year. In this slide, it is possible to observe two examples of an NDVI time series, in which is clearly notable that the whole mock wood, being a forest composed mainly, if not totally, by an evergreen species, has an NDVI value which is constant during all the year, while the mixed hardwood show that during the autumn and the winter period, the deciduous species have lower NDVI values, and so the LT status is different. The principal component analysis, PCR, was used to reduce the number of variables within our large dataset without loss and important information. The PCA was used on the vegetation index values of each pixel, and 4 different score plots were obtained. Each score plot showed the score output and of the PCA. Indeed, they support the interpretation of a distinctive forest category, showing clusters of samples based on their similarity. Close samples have similar composition, while distant ones are much different each other. The classification was finally performed with the machine learning algorithm called random forest. The Google engine scripts allow to split the dataset along with a specific percentage, with training points as 50% of the total, and the validation points the remaining 70%. The final outputs obtained for each vegetation index can be observed in this slide, and apart for litter clusters, the outputs have similar patterns. Thanks to the convolution metrics, it is possible to observe that the maximum classification accuracy is reached using NDVI and GNDVI, which both gave an accuracy of 84%. And this is due to their ability to enhance the reflectance between the red and green bands in comparison with the near band. The TDVI reached the 81%, and the heavy at the lowest value, 78%. These results show that Sentinel-2 platform can be used to classify different forest categories over a large area, even with limited input sample data collected on the ground, because we collected only 32 points. Being this remote sensing platform free and being the Google Earth Engine software an open access one, it is easy to understand that the possibility that we can get from them. So at the end, it is possible to notice that the Google Earth platform allows to a wider audience to map wide areas in a proper way. But then these maps need to be understood in a technical way. The output obtained with the high accuracy showed before ensure that this platform can effectively classify a large forest area, allowing maps to be quickly updated and thus complying with the European regulation. And moreover, needs to be highlighted the possibility to work with local underpowered devices. In order to make future steps in this research, we have considered the possibilities to obtain new classification output using both different satellite platforms and other classification algorithms. New satellite platform can be both free platform, such as the Landsat 8 or commercial constellation, which have higher spatial resolution, like the Planescope, even if losing the fact of being free of charge. On the other hand, it is possible to use the other machine learning algorithms that I showed before in the presentation, because we applied only the random forest. And probably a further step forward can be the use of deep learning algorithms, such as the diffusion of spectral image and point data method. That's all. Thank you for your kind attention. If you have any question, please, I will be glad to reply.
Okay. Thank you for your presentation, Mattia. Thank you again. Very interesting. So, any question from the audience? No hands raising. So, I have just a question, but maybe just an aspect to stimulate the discussion. In your opinion, considering your activity, the activity that you have presented during this session, which are the advantages of time series in such a kind of analysis, and especially working with different classification algorithms?
Thanks for the question. The time series allow to take account a user-defined time span to evaluate the phenological variation occurring the chosen period. By studying this forest vegetation time series, it is possible to identify periods of vegetative state and obtain more complex and accurate information to classify automatically white forest data. This larger amount of data, if managed through statistical analysis such as the principal component analysis, can be useful to identify clusters of typical behaviors of forest category. And moreover, together with my research colleagues, we are trying to define a scientific process for the identification of outliers in the time series vegetation, which can be indicators of course, sensor failures, but also of disturbances occurring in certain periods, and that can be used to understand some forest cycle dynamics. That's my opinion.
Okay, it's clear. Thank you again, Mattia. Any other question? So we are close to the conclusion of our workshop, but before the conclusion, I would like to leave the floor to my colleague, Professor Giuseppe Modica, which is one of the organizers of this workshop. So Giuseppe, if you would like to add something to our session, please. Giuseppe, are you online? No, okay. We cannot hear you, Giuseppe. Not yet. No, we are not able to hear you. You can try to disconnect and reconnect. It's our last chance. Okay. Meanwhile, I would like to thank all the presenters and all the authors for their contribution, for their presentation, of course. And thanks also to all the participants to this session for their attention. And Giuseppe? No, we are not. No, we cannot hear you. I can try to to understand your thoughts. Yes, there was a last thing that we would like to share with you. It is about a special issue. I just put the web link in the chat of this platform, and this is a special issue related to our workshop, special issue of geomatics in forestry and agriculture, new advances and perspectives. So we would like to invite you to submit a paper to this special issue. For all the information, you can use the link that I have provided in the chat, but also feel free to contact me or Professor Modica via email for other information about this special issue. So this is all for this afternoon. Thank you again for your participation and for your attention, and see you in another occasion, maybe possibly face-to-face without limitation or restriction due to other pandemic events. So thank you again and have a nice day. Bye-bye.
Good evening to everyone. Bye.
Bye, everybody.
Bye.
Hi, Raphael.
Good evening.
Good evening. I'm Vladimir, and I will be chairing this session instead of Yelena Stankova, who is in the timetable, because she's not able to join today.
Okay, no problem. We have 2 minutes before start of the session.
Yeah, we are just about to start. So I wonder if we have any of the speakers connected already. So do we have the speaker for the first paper? Gabriel or Luciana or Arlindo or Andamudi? Not yet. And do we have the speaker for the second paper, Victor?
Excuse me, Professor Korkov. I think that Gabriel is just joined.
Okay, that's great. So Gabriel, you are the speaker for the first paper, right? Can you hear us? Okay, so can you say something? Let's check if we can hear you, if we can see your slides. Gabriel? Hi. So can you unmute yourself? So you can press the microphone and the camera in the middle of the screen below. Raphael, can you help Gabriel maybe? Yes, we can. I think we can see you. That's good.
Hi.
Oh, we can hear you. That's great. Okay, good. So we have the first speaker. Do we have Victor Dostov? Not yet. I will check. I believe Anar is also here, the speaker for the third paper.
Yes, I'm here.
Okay, good. And do we have Rita connected? Not yet, but maybe she will be later. Okay, just give me one moment. I have to check the second speaker, and we will start. Okay, so welcome everybody to our section workshop on the blockchain and distributed ledgers, technologies and applications. And today we will have this session of 4 papers, and we will continue tomorrow. So I welcome the speakers, and I welcome our first speaker, Gabriel de Souza Matsumura, with the talk on vulnerabilities and open issues of smart contracts as systematic mapping. So Gabriel, please share your screen.
Can you see the
Yes, we can see it. Yes, we can see it. So welcome.
And the transition is working?
Yes.
Oh, thanks. Can I start?
Yes, please start.
Thanks. Hi, I'm Gabriel, and our team involves researchers affiliated with 3 public Brazilian institutions, being this here. And now I will talk about our publication in this workshop, Vulnerabilities and Open Issues of Smart Contracts, a Systematic Mapping. The main topics we will cover are introduction, research method, results, and discussion challenges. Here, our main goal is to reason about the open issues regarding blockchain smart contracts, and to reach this goal, we aim at searching primary and secondary papers to derive answers for our research questions. About the research method, here in the lower right corner we have the search string, and in the left we have the inclusion and exclusion criteria. We applied the search string in Scopus database in January, and in the resulting papers we applied the criteria in the first stage in title, abstract, and keywords, and in the second stage we applied in the full text. In the end, we added a paper nominated by a specialist, and we finished with 50 papers, being 32 primary and 18 secondary. About the research question 1, we have some info about the primary and secondary papers, the primary in blue and the secondary in yellow, and in the left we see the graph with the frequency of publications being corporates and journals, and here an interesting info is that the 18 secondary papers have more publications in journals than the 32 primary papers. Here in the right we have the frequency of the publications over the years, and we can see that both the primary and secondary papers have a quadratic appearance of growth. Here in this map we have the frequency of the countries, authors, affiliations, and the country that published the most was China with 16 papers. The second is USA with 9, and the third are both France and Singapore, with 5 publications each. In the research question 2, we'll talk about the problems and issues we found. The first is security, that is mentioned in our papers, and the others are privacy, performance, legality, and updatability. And the updating process can be done in the same way it's done in traditional software development, because the smart contracts are immutable. So to deal with it, some methods we found is the use of design patterns that facilitate the updating and the monitoring of the contracts after publication in the runtime. And when we find exploitation, we kill the contract and replace it, publishing a new version that have already mitigated this vulnerability. Here in the research question 3, we will talk about the categorizations and classifications of the problems and issues, and we found that they usually cover.
Oh, it seems we lost Gabriel.
It's working.
Gabriel, we lost you for a while, like 30 seconds, but it's great that you are back.
And when I stop it,
We don't see your slides yet. Can you share? Can you share the screen again, please?
Yeah, sorry. You are seeing now?
Yeah, so this slide we saw and you started talking about security, and that's where we lost you.
Oh. I will continue.
Yes, continue, please.
Yes. Security was mentioned in all papers. Privacy, performance, and legality, and updatability are the others issues that we found. And to handle the updatability issue, that's caused because the smart contracts have the immutability property. The common approach we found is the use of design patterns that facilitating the updating process and the monitoring of the smart contracts after the publication in runtime. And when we found some exploitation, we killed the contract and replaced it with a new version with the vulnerability mitigated. In research question 3, I talk about the categorizations and classifications we found about the problems and issues. And we see that they usually cover the attacks, vulnerabilities, and properties. And here the attacks are the exploitation of one or more vulnerabilities. And as an example, we have the decentralized autonomous organization attack, that one of the vulnerabilities that was exploited is the reintrance vulnerability, and to handle it, they derived the single entrance property to mitigate this vulnerability. In the research question 4, we present an initial taxonomy about the solutions that we found for the issues. And in the horizontal center of this figure, we have the life cycles of the smart contracts development. And
excuse me, but somebody grabbed the screen. I now see somebody else's screen, not Gabriel's.
You are...
Could you please unshare so somebody else also shared the screen? Yes, thank you. Thank you, Gabriel. We see your slides again.
And it's in this slide that you are seeing before, or it's...
Yes.
Yes. Okay. I will continue. Here, in the horizontal center of this figure, we have the life cycle phase of the smart contracts, being then the design, implementation, verification, that are pre-publication phases, and the monitoring, that is a post-publication phase. And here, in red are the sets, the major sets of the methods we found, and in blue are the elements of the sets that are methods that can be used in each stage of the smart contract lifecycle. Here are the main tools we found in the primary papers, being the OIENT and MIFIL for symbolic execution, Rechecker for deep learning, and ITOR for abstract interpretation. Some tools that are often leveraged are NUSMV and PROC for model checking, and Z3, Coke, Isabel Ho, and DICE2 for Turing proving. About the discussion and challenges, we will talk about 3 topics, and the first is auditing. That is the best way to increase the security of smart contracts, because the automated tools aren't enough yet to offer the same benefits of the auditing, but they will improve. And about the path state explosion problem that is mentioned for symbolic execution and model checking, this can be avoided since with the gas system utilized in blockchains, we don't have a large amount of iterations. So the explosion problem don't occur if we have a proper modeling of the gas system. And about software testing and dynamic methods, the gap is we haven't adequate execution environment for run the tests, because the best execution environment that we have is the real network of a blockchain, but each instruction that we execute will cost money. So the more adequate way to we handle this is by simulating a better execution environment that don't cost money to you test the software, the smart contract. Here are some related links that may be useful, and this was the last slide. Some questions or comments?
Okay, thank you, Gabriel.
You're welcome.
So please, questions from the audience.
Can I ask the question?
Yes, please.
Okay. Can you please summarize how that problems will influence the development of...
I have some problem to hear the question.
Yeah, I also have the problem to hear the sound. Check. I think I know who was. Okay. So the starting part of the question was to summarize the problems.
Can you now hear me, please?
We heard a little bit, but we don't hear you anymore.
So
maybe you are on mobile connection.
How the mentioned problem?
The presentation is still working?
Yes, maybe you can unshare the presentation, Gabriel, and this will ease the traffic for our participant who would like to ask the question. And I will ask my question meanwhile. Okay, I think I see.
So can you hear me?
Yes, I think now it's better. We can even see your video.
Okay, I will switch it off to save some traffic. Can I ask my question again?
Yes, please.
Okay, I would like to ask Gabriel how his results will influence smart contract development in future. So I mean that he indicated some problems with smart contract. What does he think about the influence of that problems on further development of smart contracts?
You want me to talk about the future works that we can infer from these results, these research questions? Is this? So, in discussion challenge in challenges, I talk about the auditing. One thing that we can do is try to automate the auditing process the most we can, so inner developers can enjoy more benefits, more profound security analysis. But it probably will not be good enough as auditing. And there are other things that we found that are interesting to use in future works. One of them is the use of machine learning that have showed better accuracy in finding the vulnerabilities. And other question is the automatic exploitation of vulnerabilities. Try to automatize the realization of attacks to using some risk, for example. And I think it's interesting, and I already initiated a review about the use of the evolutionary computation to security, and I will try to involve this with the smart contract development, because it can benefit the verification and the monitoring of the smart contracts.
Thank you. Gabriel, I also have a small question. So there are many different blockchain platforms existing that support smart contracts or conceptions similar to them, like chain code. So did you consider only one platform, Ethereum, or did you consider many platforms? And if you considered many, then what is the specific of smart contracts in the different platforms? Do they have different problems of security, vulnerability, etc.?
Yes, the papers, the resulting papers that we have are mainly about the Ethereum blockchain, but we utilize the other platforms too, but the major are Ethereum. And the difference is that some blockchains don't utilize a Turing complete language, for instance, and some of them utilize more conventional languages like Java, and the Ethereum utilize the Solidity, Viper, that they are more recent languages. So they are being developed yet. There are some problems, and there are problems related to the network of the blockchain that can be that can have problems of scalability, and this can be an issue. And there is the question too of the blockchain is public or consortium, private, that can influence too. And there are many differences that we need to consider when we start the development process. These are some of them.
Okay, thank you, Gabriel, for your answer. Does anyone else have questions to the speaker? Okay, thank you, Gabriel. Thank you for your talk.
Thank you.
And we move on to the next speaker. And next speaker is Viktor Dostov with the talk on comparison of deterministic, stochastic, and mixed approaches to cryptocurrency dynamics analysis. Yes, Victor, we see your screen. But can you say something again? Because I thought we had some problem listening to you again. We do not hear you now, but we saw the slides. No, you have some problems with the sound again. It's very, very silent, but it was fine when you asked.
Can you hear me now?
Yes, now it's much better. Now it's very good.
So finally, we have it done. Thank you so much. Okay, I'm going back to my slides. So now you can see slides and you can hear me fine. So thank you so much for invitation for presentation. And actually, I would like to talk about very general problem and discuss it on specific example. In that picture, you can see some dynamics, some graphs for cryptocurrencies. The graphs specifically are number of active Bitcoin and Ethereum wallets. And you can see that the graphs are very interesting because they combine a lot of random noise with definitely visible trends. So some time ago, we started to study such kind of system, specifically cryptocurrencies. And we met actually two ill-determined questions. First one, which is the best interpolation for such kind of noisy curves, and what is an approach to best prognosis for such kind of curves. Of course, some kind of approaches already exist, and we try to use two approaches. First approach is deterministic approach. Let's forget about noise. For example, we can use average values. For example, in that picture, we averaged Bitcoin and Ethereum data by years. That curves are quite smooth, and for smooth curves, we can use some kind of standard deterministic approach. Our favorite one is Bass innovation diffusion equation. Simple equation looks something like that. We use a little bit more complicated, but not too much. And this equation discusses dynamics of the audience. In our case, is a number of wallets, of active wallets, depending on current amount of wallets, X, and some coefficient where A describes customer attraction rate, how often customer open new wallets, and B is fatigue factor, is the probability that a customer just stops to use the service for some reason. And N is maximum size of the audience. Actually, it's a very well-known equation. This is very well-known equation. And actually, when you make the decision to buy a new phone, and if you make a decision, for example, to join a new social network, your behavior is quite well described by Bass equation. And you can see that our analytic curves, which give solution, describes that smooth behavior pretty well. But of course, Bass equation does know nothing about noise. On the opposite sides, we have some stochastic approach, and probably more famous one is Arima algorithm. Arima is a kind of autocorrelation algorithm which says that current value, for example, wallet number, is depends from previous values of the values in previous moment of time. It's called autocorrelation, plus some amount of random noise generators. So you combine some kind of autocorrelation and random noise. And Arima might be quite good, and people use Arima trying to predict share market behavior or cryptocurrency behavior or even weather behavior, something like that. But the problem with Arima is that Arima is absolutely agnostic. Arima is quite mechanical algorithm. You just take data, put it computer, and Arima does know nothing about systematic behavior. So very natural idea is to combine two approaches, to combine stochastic and deterministic approach. First, we did it very simple way. We make some kind of approximation for bus equation. So we found best A, B, and N. Then we extract bus model from real data, hoping that the residual will be a kind of random noise, which is described pretty well by Arima model. And then we apply Arima model to the difference between bus equation prediction and real data. And of course, we're going back to the question I raised at the very beginning of my presentation. What does mean good interpolation for such kind of noisy model? First one, we hope that for Arima, the parameter D will be equal to 0. It means that Arima does not need differentiation or something like that to extract a systematic trend. It works pretty well. So instead of differentiation, which is usually used in Arima, and which is always combined with some loss of information, we have Arima with no differentiation. Also, we would like to give small parameter p, which means that autocorrelation sequence is quite small. So if we use some kind of model, we don't need to take a lot of previous data to predict the further data. Next, the evident criteria, we hope that if we use combined model, standard deviation between models and between model and real data will decrease comparing to pure bus model and pure Arima model. And final one, we hope that it will provide for us quite a good interpolation, extrapolation, which can be used for practical results. And really is true. In that picture, you can see three types of model. Red one is pure Arima, yellow one is pure bus, and green one is combination. We see that combination is much better than pure Arima, and combination is slightly better than pure bus. And what is quite important, that combination is visually quite good fit to real data. Of course, it's not a definitely exact prediction, and you cannot use our model to become rich trading cryptocurrency in the cryptocurrency exchange. But my main message is not only say to you that we can use some kind of combination of model to get better results. My main message is that we need to think about some kind of general approach of modeling of such kind of random data like cryptocurrencies. First question is standard deviation good for very noisy curves with trends? We don't know to the moment, because evidently, if we apply standard deviation minimization to such kind of curves as cryptocurrency, for example, Arima might be cheated by high periods or hidden trends. What does it mean? In our curves, we have some period when amount of wallet decrease or increase dramatically. It depends on some kind of advertisement, some kind of external events, some kind of approval of cryptocurrency by regulator, or otherwise some kind of denying of cryptocurrency by regulators, by central bank. So Arima might be cheated, but such kind of event very easy. Second question is probably more mathematical. Does Arima commutates with bus approach? What does it mean? If we apply Arima first and then bus next, and after that we will apply bus first and Arima next, will the result be the same? We need to study it. It's still in the progress. And the last question is about simultaneous optimization. What does it mean? In our study, which I presented, First, we optimized A, B, and N, and then we optimized Arima parameters, including P and Q. It's very easy because we have different ready-made computer algorithms, computer programs, computer procedures in Python, for example, which made for us optimization for bus and Arima. But theoretically or practically, we can write our own algorithm, which will optimize a final result, simultaneously changing A, B, and P and Q. And for us, it looks like a very prominent direction and very interesting question. Is the accuracy of simultaneous optimization much better than step-by-step optimization? So thank you so much again for possibility to talk here. Thank you so much for hearing me. And if you are interested in questions connected with cryptocurrency or random behavior modeling, you are very welcome to write me something or type me something in the messenger. Thank you so much.
Victor, thank you very much for your talk. So now please, questions from the audience who would like to ask Victor. Victor, I have a question. So you have a large experience with different kind of currencies, cryptocurrencies, usual currencies, electronic money. So can you say, is there any specifics in cryptocurrencies compared to other kind of money? So did you see when you analyzed these dependencies something different from different cases, from other cases?
Okay, thank you. This is a very interesting question. I like to talk about that question so much. Along with the study cryptocurrency, we see more and more coincident with common currencies, with fiat currencies, how we call them. But there is a big difference because for fiat currencies like a dollar or a ruble or I don't know, peso or something like that, we have quite a systematic behavior and random noise for that currencies are quite small. Therefore, we can use bus to make quite a good prediction of currency behavior. Even better, we can make prediction. Even better, we can make even better prediction for example, electronic money behavior, because electronic money behavior are very well determined. For cryptocurrency, generally, I believe we have absolutely the same mechanism of evolution, but the role of rational reasons of systematic behavior for cryptocurrency is much smaller than random behavior. So we still need to have some good mechanism to predict such random-based payment instrument behavior.
Thank you. Do we have more questions to Victor? If not, Victor, thank you again. That was a very interesting talk. And we are moving on. So the next talk by Alexander Bogdanov and a number of co-authors will be presented by Anar Faradjov. And the title of the talk is Testing and Comparative Analysis of the FBFT-based DLT Solution. Victor, could you please unshare? Yes, we see this.
Can you see? Okay. Well, yes. I'm glad to give a report on this topic in this conference. Before diving into the depth of the matter of this paper, I think we should, sorry. Can you see now?
Yes, we saw.
Okay. We should clarify some basics. Namely, we should understand.
Excuse me, Victor, are you still sharing the screen? I think we see your screen now. So can you press the button? Yes. Anar, can you share it again?
Okay.
I think we don't see this.
Now must be much better.
Yeah, Victor, okay. That's fine now. But we don't see the screen of Anar anymore.
Can you see it now?
Yes, we can see it now. So please
okay. Well, as I said, we should understand what the consensus protocol is. because it's a crucial part of any distributed ledger system, and sometimes of some another types of distributed systems. So now there are two main types of such algorithms, such protocols. First one is Nakamoto style or Bayesian based algorithm. The most notable feature of algorithms of this type is that they imply the presence of decisive leader. It is the leader of the overall network or the part of the network decides whether the block of information should be committed into the ledger or not. And the second type of consensus protocols are voting-based or BFT-style protocols. Here, BFT stands for Byzantine fault tolerance. That refers us to famous Byzantine general's problem resolved by Lamport et al. And in this type of consensus protocol, there might be a leader, but it doesn't play a crucial role. And the decision making is up to special voting protocol. So we will consider two algorithms of the second type of BFT style protocols. So in this research, we examined two platforms which have pretty much in common, but not consensus protocol. So the first one is Hyperledger Sawtooth and Hyperledger Umbrella. Hyperledger Umbrella. It's a blockchain framework that incorporates different consensus algorithms in itself. And one of them, and one that we will consider now, is practical BFT consensus algorithm, which is quite classical, and there are quite an extensive body of literature on it. So, and the second one is the second platform in consideration is BGX, BGX DGT. It's also based. This platform is also based on Hyperledger Sawtooth, but it uses quite another type of consensus protocol, which is called FBFT. Well, unfortunately, it is not described pretty well in literature, so I think it is important to reveal some main principles. Basically, FBFT stands for Federated Byzantine Fault Tolerance, and this is quite modification of PBFT algorithm, but for federated networks. These networks consist of several almost independent clusters. So, and it should be used in such networks only. So the algorithm itself consists of 4 macro stages and dozens and dozens of micro stages. But macro stages are described on the screen. The first stage is initialization. The second is committing transaction within initiators cluster. Here, initiators cluster and initiators node is denoted by I. The third stage is committing confirmation to the members of the other clusters, and the last one, the last stage is committing, spreading of the transaction all over the network. So let's get to testing itself. Tests for this research were committed in 4 different scenarios, which will be described a bit later, and 5 different topology configurations of 6, 12, 15, 18, and 21 nodes. And it should be mentioned that increasing of topology was provided by not increasing of the number of nodes in each cluster, but by the increasing of the number of clusters. It's quite crucial. To compare the performances of aforementioned platforms, we used 4 metrics. 2 main metrics, committed transactions per second, and volume of network traffic on validator. So this is the volume of network traffic on validator is the meaning of it is the volume on the most crucial part of the node of the blockchain network. Also, we have used 2 auxiliary metrics. First one is committing rate. So it helps us to gauge how much, which fraction of sent transactions were actually committed. And the second one is average resting state volume, is almost the same as volume of network traffic. It's actually network traffic on validator, but in the stage when no transactions are committed. So let's get to results, and on these tables you can see results of first 2 tests. First test was about single transactions committing. It means no transactions were sent until we haven't received the confirmation of committing for the previous one. And these testing results show quite promising results, exactly for BGX. I mean, here we can see that BGX appears to be quite scalable in terms of volume of network traffic on validator. So it shows quite flat dynamics. And also it performs a bit better than Sawtooth BBFT in terms of CTPS. So, but the second test, which was about asynchronous streams of transactions committing, it means that we try to commit transactions asynchronously from different clusters. So the results of these tests are less promising, actually, because as we can see here, CTPS for Sawtooth BBFT increases linearly together with the increasing of the workload, the number of clusters and the number of working streams. So it happens because Sawtooth unites simultaneous transactions into blocks and tries to commit block itself, which contains several transactions. Meanwhile, we can see that CTPS dynamics for BGX is pretty flat. And moreover, we see here that committing rate drastically falls as workload increases. Well, here you can see a graphical representation of this data. And let's go further to test 3 and test 4. They explain the results of the last test, test 2. We can see here that at the test 3, we try to commit simultaneous transactions from different clusters. And in test 4, we try to commit simultaneous transactions from every node in the network. And we can see that Sawtooth done pretty well. Committing rate falls a bit only in the last test on the maximum workload. Meanwhile, for BGX, we can see that committing rate is always 0. There were no transactions committed. And we think that it happens because BGX prefers not to choose at all between two simultaneous transactions, and he just drops away both of them. So, and also in terms of average resting state volume, we can see that Sawtooth performs quite better than BGX. So for conclusion, we can say that the current version of BGX might be implemented in highly distributed systems, but without strict reliability requirements. Meanwhile, Sawtooth PBFT is quite less scalable, but pretty reliable. Well, thanks for your attention. I'm open for questions.
Anar, thank you. So please, questions from the audience. I have a small question meanwhile. So Anar, you compared two platforms, Sawtooth and BGX or DGT, and you gave some overall estimation in the end, so when each platform is preferable. But do you think you can give some examples of actual applications that would suit better one or another platform?
Well, let me think a bit. So as far as I know, BFT-based algorithms are used in highly reliable systems such as Boeing aeroplanes and so on. So I think it's obvious that BGX shouldn't be used in such systems. Meanwhile, usage of Sawtooth is quite a philosophical question, I think.
But do you think that these BGX artifacts that you discovered are just a problem of this intermediate version, and they will be fixed, or this is the feature that is should be there?
I hope that developers will hear us and hear this report, and they will try to do something with those problems. Because actually, honestly, it seems to me that this system is shouldn't be implemented anywhere yet. Well, it's not done.
But considering that DGT is developing solutions, so it's new and it's still in active development, and if we consider that there is the problem like this, I believe it's much more promising that Sawtooth. What would you say? So, what are the advantages of DGT compared to Sawtooth?
Well, yes, the main advantage of using BGX instead of Sawtooth is its scalability, high scalability. Well, because Sawtooth BBFT needs quite a lot. The workload of overall system in Sawtooth increases as in power law. When you increase the number of nodes by n, well, the workload of the overall system increases by n squared or more, and in the power of 3 maybe. Meanwhile, FBFT, BGX in particular, tries to smooth this problem. It's not absolutely scalable, but it's done some. It strives in that way. So, did I answer your question?
Oh yes, absolutely. I think that's a very good answer, and which means that we should still keep a close eye on the DGT development, as it's quite promising technology, hopefully. Okay, so Are there more questions to Anar? Probably not. So Anar, thank you again.
Thank you.
And we move on to the next talk by Rita Tsepeleva, and talk on the topic implementation of the cross-blockchain interaction protocol. Rita, could you please
Yes,
share?
I'm here.
Yes, I think we see your screen. Yes.
Okay.
Yes, so please, you can start.
Okay. Today I prefer to talking about decentralized finances. Decentralized finances is an industry that is trying to replace our usual banking operations with open source protocols, mainly to make them decentralized. It means that it tries to remove all control of the state and banks over user funds. These protocols are created using smart contracts, special software code that is published on the blockchain. This way, a code is written that is able to replace traditional services for users to provide loans, insurance, and other things. However, all of this has many disadvantages, and one of them will be discussed today. The problem with the DeFi industry is as follows. Initially, decentralized finance was conceived as a single ecosystem whose products can easily be compatible with each other. But at the moment, there are a huge number of different blockchain platforms and no fewer decentralized applications are deployed on them, and they include financial ones. The problem is that blockchain platforms are not able to independently communicate with each other and transfer any information to each other. After all, initially, each blockchain is an independent and automatically working unit. It turns out that DeFi applications are scattered over various networks between which there is no communication, and it means that there can be any questions about a single ecosystem. It was very general and abstract problem. And now let's take a closer look at the problem using the example of a specific task from the company MyWish, which owns the Wish token. The token is located in the same network, Binance chain. This restricts its use in some way. To solve this problem, I was given the task of transferring the token to other blockchain networks and wrapping all it in a user service. Despite the specificity of the task, the results of this work can be extrapolated to more general classes. So before developing our own project, we analyzed existing solutions, one of which is Polkadot. Polkadot is a network connecting blockchains. It provides a structure that allows you to quickly exchange your data from different blockchains. The ecosystem of the Polkadot consists of the following components. You can see them on the screen. Many projects are already in development on the basics of the Polkadot. Some of them partially coincide with our goals and objectives. For example, PolkaSwap project. First of all, this is a decentralized exchange. It provides a structure that allows user to conduct efficient and fast trading of their assets. In addition, PolkaSwap allows you to transfer assets from one network to another, which also expand the capabilities of users and their assets. Another solution to the problem of cross-chain token transfer is a blockchain bridge. This is a link that connects two blockchain networks and allows you to transfer any public information between them. Most bridges for transferring token between networks use the mint and burn protocol. It means that when a token is wanted to be transferred from one network to another, the token is burned in the sender's network, and the token is issued in the recipient's network. These projects have their drawbacks. A significant drawback of projects on Polkadot is security, and the disadvantages of blockchain bridges are associated with high fees and in the essence of the mint and burn protocol itself. So, taking into account all the above solutions with their advantages and disadvantages, we developed our own idea of the Wish Swap project. Before the development, an analysis of the network to which it's necessary to exchange in the first place was also carried out. It was decided to develop a mechanism to transferring tokens between the Binance chain, Binance Smart Chain, and Ethereum networks. To do this, it was necessary firstly to create smart contracts for analogs of the Wish token in the Binance Smart Chain and Ethereum networks. Secondly, we should create bridge contracts for tokens in the same networks. We should create backend. The backend will link contracts in different networks, and only our backend will have access to cross-chain functions of our contracts, and tokens will be distributed at his command. Among other things, it was necessary to wrap all this in a web interface. So I've created the wrapped Wish and Binance Wish tokens in the Ethereum and Binance Chain networks. Binance Smart Chain, I'm sorry. It was necessary to make them in order to create an equivalent of the original tokens in this network, in these networks. Also, I've created bridge contracts. They contain the implementation of cross-chain functions that only our backend has access to. They store the entire numbers of equivalent tokens issued in this network. Next, you will see the final architecture of project, how it should work. The user logs in our service, logs through an electronic wallet, I mean MetaMask or Wallet Connect. A form opens in front end of him, and where he selects the exchange networks, the number of tokens to the amount of tokens to transfer, and the recipient's address. Here, the commission or fee is immediately calculated for him. Next, the front end collects all his information, forms the transaction, and sends it to blockchain. Network registry scanners see the transaction for the exchange contracts and send message to the backend, and in turn initiates the transfer of tokens to the final recipient. Our project solved the security problems of previous solutions by using smart contracts for cross-chain exchange, not ordinary addresses. The following slides show a comparative table of our solution with third-party ones for a number of indicators. Below you can see diagrams that clearly shows the advantages of our solutions over third-party ones in terms of the amount of gas consumed per transaction, the amount of fees, the number of available networks for exchange, as well as a number of available payment methods. The project is planned to be developed by connecting more and more new networks, as well as improving the internal structure of blockchain bridges. So, on this slide you can see our results, which work we have do. The code of the contracts and the backend is available via the links. Thank you for attention.
Thank you for your talk. So please, questions from the audience. Rita, so could you clarify, maybe you were talking about technical solution, like how you implemented this, but I have more generic comment or question. Could you give some examples of actual scenarios or applications that would require interaction of blockchains first, and then, as I understand, you have this service in production now running. So what can you say about users? Is it indeed on demand? So are people using it, and what are the statistics of usage?
Yes, this service is working now. It's available on MyWish platform. Users can send their Wish tokens from networks Binance to Binance Smart Chain and to Ethereum. Can you clarify and maybe repeat your question again?
So the first one, if you give any statistics, like how many users do you have? So how many people use that? Maybe you remember approximate numbers. So you started this service, I believe, like half a year ago or so.
No, I'm sorry. I just don't know how many people use it, but I know that for our platform, for our users, for MyWish platform users, it's popular service.
But can you give some example of an application so people transfer money from one network to another because they want to do what with those new tokens in the new network? So
For example,
yes.
For example, users know that, for example, in Ethereum, they can put their tokens to another smart contract to stake them, to deposit them, but their Wish tokens are laying in Binance Smart Chain, and they want to stake them maybe in Ethereum network and to give some profit for it. Maybe this case, users can transfer their tokens between networks, and just they want to give profit from their funds.
Okay. Yes, I see. Do we have more questions to the speaker? Probably not. So Rita, thank you again.
Thank you too.
Thank you again. And with this talk, we conclude the session of today, but we will still continue tomorrow morning. So I welcome everyone to join us tomorrow. And we are done for today. Thank you for participating.
Vladimir, thank you for moderating. It was quite interesting session and well moderated and done. Have a good evening.
Yes, it was interesting because of the speakers of your talks, and I also think it was very interesting. So thank you for joining us, and goodbye. See you later.